discuss the compiler steps and how the high level language is converted into machine targeted code, that is executable, the final code. So there are total 6 phases that we have yesterday discussed. So we have in brief or in detail we have discussed the only first 2 steps that compiler use. Okay, that how the lexical analysis work and how the parse trees or the syntax analysis use the parser to check the all the syntax and generate the parse tree for them. Okay, so this is a context that we have to cover in these sessions. So this is general compiler infrastructure that where the lex and yak, these are the two scanner and parser are used in your compiler. So you can see in details how the general structure about that code, what are the regular expressions we have to use in scanner. So what are the different primitive functions or the context that they have to use for the writing the regular expression. Okay, and then we can run the code. Okay, so we do some practicals for this context. So be prepared for the generating, use the laptops, means to whenever I'm telling you to write the code or something. So why study the compiler? So first is just a minute. Okay, so basically these are the points that we have to know to why we study the compiler. First, enhance the understanding and understanding the programming language. Okay, now we have to in deep knowledge about low level machine executables, so that uh, when you know key how the code is actually executed in your machine level, so that you have to in deep knowledge about the that particular instruction set that actually execute into your CPU in low level. So write a compiler or an interpreter that various programming language like the domain specific languages like Java, JavaScript, C++, C Sharp, modules 3. These are the uh, languages they have to either interpreter or the compiler they have to use for the generating their respective target code or the machine code. Okay, so another thing that to learn the various system building tools like Lexia and other means make or configurations. These are the tools that they have to support it to build the your programs. Okay, to learn to interesting compiler theory and algorithm. So we are not going in detail about the theory part or algorithms, but when you learn the compilers, that the very interesting things they have to know what are the things you have already studied in different domain, different subjects, like all they are combined used together and build the compilers, means TCS algorithms, then low level programming, the comes everything come together, and then all the interesting parts that we have to learn in compilers when you have to uh, go in detail about the compiler theory. Then to learn the ability of the programming in the modern programming language. So these are the another point that why we study the compilers. Okay. Compilers are the translator in a short film. So this is the input language L. It translate into the L dash. This is the output language. So just one language convert into the another language that is understandable by the machine. So first here is the various forms of translator that we have already knows. So let's say example here. So L is a C++, ML or Java, that the whatever the translation happen from this particular language is the assembly or the machine code. And which translator we have to use here? We have to use the compiler, right? So assembly language, that the target assembly language is converted into a machine language, that assembler is a translator used for the conversion of this object. So next thing, so object code that you have already generated .o files, right? Before the generating the executable file. So this object file is converted into the object a.out, that is called the translation happen in between the linker or loaders. Okay, so macros text, the text as a final uh, output for this particular language. So it use the micro preprocessor or the CPP that you have already know about how the micros are replaced in the assembly. These are the another examples, and many more that you can see in real examples in your machines, like gzip or the conversion of one form to another form. So these are the examples of various form of translator use. So next part. So this is the general compiler infrastructure that we have to already see this all the 6 steps, right? So this is the first the program that you have the stream of characters, right? Passing to the scanner, that is a tokenizer. It converted the tokens, that tokens as an input of your parser. That parser do the some semantic structures, that semantic routines, that intermediate code representation, right? So that representation intermediate representation that transfer to the code optimizations and transformation analysis, uh, and then it generates another form of the intermediate representation, that is the optimal way, and then final code generation, and then your assembly code is generated, right? This we have already discussed in brief this all the steps in previous session, so I am not discussing again. So these are the 2 points that where these 2 tools are using. So we are in deep understanding the lex and yak. So in scanner, that is your lexical, the flex scanner, or yak is your default based compiler, you parser use in your compiler for the generating the parse tree and validating the syntax. Okay. So these are the indie means if you explore for the 6 steps to more phases. So you can see the sequence how the these phases are look like. So source code, with lexical analysis, sequence of token, then syntax analysis, that is the parser, that abstract syntax tree they have generated. Then they have to pass to semantic and types analysis. They validate the abstraction syntax, right? Then intermediate code generation. That intermediate code generation go to the optimization. Optimization is a better intermediate. The next form of the intermediate code, that is a better and optimized way. So that pass to the machine code generator. The final code is generated, and then after that they have to some instruction schedules and registers and allocation. That the faster machine code is generated, and then final a.out is created, and then you can run your program. So these are the in detail translation of your programs, one form to another form in compilation. Okay, so here, so what internally happens? So that's I already told. So to trigger the source code, let's say lexical, that ASM. So this using the LMLex, that the library. So that is sequence of token, that parser, let's say AS3 to 4, using the ML, the another library, that Yak library. So then abstraction, that ASM5, then validated ASM6. So these are the conversions of the internally happens in the when a compiler translate the any code that you have passes to the compilation. Okay. So now in general structure about the these two, because whenever you use these two tools, okay, so you need to be linked together that particular things. Okay, so in this uh, Lex and Yak, so you have you can scan the tokens individually, but you cannot means execute the parser independently, because they require the tokens, sequence of tokens, that as a form of that generated by the scanner. So always that whenever you write the Yak program, so it use the scanner to scan the tokens and pass to the parser for the next page. So you can use the combination of both. So here, so extension of the file is lex is l.l and yak is .y. So when you compile using the tool that the lex, you can install the your machine, that is flex library, and for yak you can use the bison. So bison is the parser that you have to inbuild supported for the yak parser, means that a yak command that you have to use. So once that file is get compiled, means you execute and compile with the lex library, so it generated lex not y not c. This is the automatic generated the c file. So you don't need to be this is a translator or the intermediate code that they have to generate it automatically for the compilation, and then you can generate the final output for the validating the your code. So whenever you run the yak program using the yak command, so it generate the one header .h file, that is a header file that you need to be included into the your lex file, because you need to be share the tokens using these files. Okay, so whatever the prototypes they have to use, the predefined functions or the variables that you need to be accessed through the parser and lex, then you need to be include this file into the lex file. Okay, so then once you pass that compile the yak file, so it generated y.tab.c, that is the lex yylex, that's the token that they have to use. And finally you combine this all compile these two files using the your compiler, gcc compiler, and generate the a.out. Okay, so both our tools have their structures, I mean the sections are the same, but the some uh, whatever the rules are they have to use that differently. Okay, so lex is specifically the generated C code for the lexical analyzer. This is canon is a token pattern specified by the regular expression. So in lex, so we have to know about the regular expression, how to use the regular expression. We need to know about the basic primitives for the regular expression that we have to use in lex. Okay, whenever you write a rule for the scanning the token into lex program. In yak, that it generated lr1 parser. Okay, so that is a syntax analyzer, is a parser. So I think you have to learn the LALR, left to right, right to left, ahead. One is an ahead parser, right? LR1, LR2, or LL parser, or top down parser, bottom up parser, that the use in the uh, in this syntax analyzer, that whenever the you use as a grammar, right? So BNF rules, the grammar that you have already studied into TCS, right? Okay, so this generator, how the scanner is generated. So helps to write the program, those control flows indirectly in sequence of regular expression of the input string. So whatever the code you have to return, so that they have read by characters, and whatever the regular expression match, that the longest strings token it is generated. So is a regular expression plus associate action. Okay, so whatever the rule you have to define, that they have to lex use, and the using the yylex is return the longest matchable token, that particular input with the regular expression into this particular file in lex.yy.c. Okay, is there any question? Hello.
No, sir.
Okay, great. So let's move for the next, that how the structure of Lex specific file. Okay, so is working. So the read part is required. So means that is a rule that is how to define. So there is a sections. There are four main sections in your program. So first is a percent opening bracket, closing bracket percent. This is C includes that you have to use this some standard libraries that use in C, like print or string libraries that you have to use. Then after you can define definitions that different say variables declaration definition they have to use. So we have to see in detail. Then after that rules that you actually the required part. So percent in percent whatever the in between you have to return, that is a mandatory part. So and after the rules that you can write the some user subroutines like our normal functions that we have written C language, like that you can use there. So how the rule line is oriented. So first that they have to two column rule. So first that is a regular expression and second column is action. So in between you can give the space, white space or the tab. Okay. So that the regular expression is the beginning of the line. You cannot space uh, in the front of the regular expression because it throw the error. So it's always start at the beginning of the line. And action, so that a single action you directly return that action, like you need to print something, so you directly use the C statement there, right? So let's say printf or the whatever the variables you have to print, so you can directly print over there, or you can assign the directly token to the definition. Okay, so in action, that if there is a multiple statement that you have to use some processing that, so that time you can use the bracket, okay, curly bracket, that you can specify the normal C kind of statement inside that bracket. Okay, so whatever the unmatched input of the characters or the copy to the standard output, so those have not matched directly printed on the standard output. So you whenever you write the program, so you need to be make sure that the so you write a rule for that, how to ignore the cases. Okay, so you don't need to be print any unwanted unmatched token or string into your final study out. Okay, so these are the predefined variables and functions that we have to use in our program for the writing the Lex program. So these are the things these mostly widely used in our Lex scanner. So first Lex, that is called to invoke the lexer and return the token. So you can this default, if you not mention that, that is yeah default, they have to add it the library when you have compiled the program. So whenever the yylex means lex dot so lex dot yyc, this file is automatically they have to add it that function and it return the tokens. Now this is a pointer, character pointer, text, that is a match string. So whatever the token is match, they have to store that into that particular pointer. Length, so you can get the length of how much characters in that particular tokens. So that will return the length of the matching string. So YYLY, these are associated token, associate with the token, value associated with token. What value they have to associate. Then this is a wrap. There's a function that return the one if done. If zero, then it's not done. So wrap up, that means that if the your input is end, then this function is called and it return the one or zero. So if run, it return the one, it means done, and zero is not done. So again it try to scan the next character streams to generating the tokens. These are the file pointers that you have to use to output the file or input the file. So these use whenever you pass the command line file to reading this as an input. So you can use these two variables, the pointers, file pointers that assign the output and input whenever you write the output into file. Initials, that the initial starting conditions. Begin, that is a condition switch bit starting condition. Echo, that whatever the matching string you have to print, that you use the echo. Okay. So these are another pattern matching primitives that we have to use in lex that associate with the regular expression. So I think all of you have writing the regular expression in TCS, right? So in given grammars, you can write a valid uh, language or the regular expression for that, right? So for the A and B, so you can write all the starting with A or ending with B. So you can generate the regular expression and validate using the automata. So here that dot is any character expect the new line. Okay, so in you don't get the confusion between the TCS primitives and here regular expression primitives, because whenever you use the plus in TCS, that is a concatenation, right? But here it not a concatenation. It is a one or more copies of the preceding expressions. Star, as of you know, that zero or more means that copies of the preceding expression, the whatever the expression you have to use. Question mark, it zero or one copy of preceding expression means if you use a question mark, it means that it is a one or more zero or one copy of the expression or that a. So use the caret that beginning of the line, that whenever you use this dollar is the end of the line, right? So we should or the condition that either A or B, that you time you can use the pipe in between. If you want to grouping the characters, that you can use the brackets, okay, and then you can apply the uh, previous or the above primitives, that plus star or question mark, that the generating the that copies of A and B's, okay. Then this is a string returner that you directly use as a string. This is escape all this work. So means they directly use as patterns A plus B. It not means A will be the occurring one or more times. No, it is a string. Consider in double quote whatever you mention in the double quote. So that pattern they have to looking into your input string. That class characters that you have to know about, that used to mention that the en at least that any one of the characters occurrence in that character class is matches, it return directly. So you can use bracket a dash z, means a to z, any character in between a to z, they have matches in your input string, they return. So here is a few of the examples that we have to use the primitive matching, pattern matching examples that using the primitives. So let's first expression ABC, that is a direct ABC matching. There is nothing. This is just as a single string as a token. If you use ABC, that means that the patterns is matching with that particular expression is AB, ABC, A, B, C, C, A, B, C, C, and so on. So it means that AB, at least AB is the starting, and then zero or more occurrences of the C. Now ABC plus that, it means at least one C's, one or more C's are occurrences in your expressions. So that is an example like ABC, ABCC, ABCC, right? So again, that group of the characters that we have to examples. So these are the examples you have to follow the whenever you write the any tokenizing the your program. So you appropriate expression you need to be written into the rule of the lex program. Okay, so you have to know about or write this kind of expressions. So So next part is regular expression. So I think all of you have idea about the how to use a regular expression, right? So can you tell me this, these are the few exam I mean uh, regular expression uh, questions that you need to be answer or explaining what are the pattern they have to generate it or the regular expression. So here is the x belonging to the sigma, that star. The x is beginning with the 0 and end with the a 1. So you need to write the regular expression for that. So so can you write that regular expression? How actually that regular expression is for the first one? I'm waiting for the couple of minutes. So please type the your answer on the chat box. So I'm waiting for the next 2-3 minutes. Okay, let's take a 10 minutes of time and complete this all the regular expression. I need to input output means in the chat box. So each one have their own set of regular expressions. So provide me that all the regular expression that we have to. Then we are move for the next. For the using that we have to write the program. So all of you see my screen, right? So open the textbook
Yes.
or the notepad in your machine and just write down the regular expression for these 6 examples. So I'm waiting for the, so time is 10 minutes. So you need to complete all the 6. those are done. So just ping me. Done. Hello. Okay, fine. So I will give you the homework or the assignment, that first assignment to this course. Okay. So I will share this all the example in that problem statement. So I have the another problem statements that you need to be write the regular expression for that. So next session we have to take some regular expression discussion, and then we can use that regular expression for using the writing the Lex programs. Okay. So I have already discussed the structure, how the structure is look like. So let's see the actual program that we have to return in Lex. So in next session, we have actually write that using the whatever the assignment that I have given to you. We have used all these to write the Lex program for that. So this is the structure that how the look like. So here that includes part that you have to include and define the variables, externals, everything, definition, that function definition that you have to use. This is the empty rule that you can skip, just use the semicolon, that nothing to do with the space. Then this is the one that rule that we have to match with A to Z, it's a character class, and we can check that letter or number. So if that value that associate with that assigned to L val, and then if this particular pattern is matching, it's written the letter as a letter that they just match. This is a letter, and if the pattern is matching with 0 to 9, the star, it converted that into the A to I, that integer string to integer, and then it's written as a number. And expected that whatever the matching with the alphanumeric value, it return into the C, as it is the rule that they have to return whatever the pattern they have to match with this particular string. So we have stop here. I share this all the problem statement that is your first assignment for these sessions. So you need to be write a regular expression for all these examples and submit it to next before the next lecture. So we have to use all these regular expression to write a Lex program in the next session. Is there any question? Hello.
No, sir.
Okay, fine. Then I will share this on your module. I will add it that into module assignment, so you can submit it that on module itself. Okay, and be ready, and that you have to write the justification for that. What you can also verify these expressions are valid or not. Means whenever you writing a regular expression, it should be the matches with the pattern that expected with the statement. Okay, fine. So we stop here today's session, and we'll meet on the Friday. I think we have the session on the Friday, right?
Yes, sir.
Okay. Thanks, guys, for the join.
Thank you, sir.